Well, hi, good morning. Thank you so much for coming and joining me in my shop here today. It is October 13th. Holy smokes, I haven't been in my shop for, well, I don't know how long it is, actually quite a while. And the reason is I hurt my poor back. Twice in a row I hurt my back. Goodness knows how I managed to do that. Fell on the stairs. Why? Okay, so I know the first step. The second injury, I was just bending over and twisting a little bit, and doing it awkwardly because of my earlier injury, and all of a sudden I had what I'm pretty sure is a facet or facet dislocation in my lower lumbar. If you look at your let's talk about my spine for a minute. If you look at your spine, you have the main circular component, with your spinal cord going down the middle, and then sticking out of it are some wings that kind of go into your body, and then sticking out this way are a couple of things called bony processes, but you can think of them as outriggers. There's two pieces that come out like this. So every one of your spinal things has these two pieces sticking out, and they stick out towards your back. You can kind of touch these, and then each one of these things out at the end here, out at the outrigger end, is connected or jointed to the one below, and the one below, and the one below. And so all these little outriggers are designed to keep your main spine from moving too far in any given direction. They're the limiters in that. Now you can dislocate these. If you look at one from one of your vertebrae and one from another, and in between is some cartilage or something like that. I guess they're kind of in contact here a little bit. If you move if you do what I did, they'll actually kind of disconnect. They can get stuck. I don't think mine got stuck. I think what happened to mine is it went thump thump like that, because that's exactly what I heard. I felt this thump thump in my back, thump thump. I think that's what happened. And of course, that's supposed to be here, or anywhere, or here, or anywhere other than right there. And if you do manage to separate these things and dislocate them, you're going to stretch tendons, muscles, all that kind of stuff. That's what happened to me. So today I can stand up quite straight. Typically you can't stand up straight in this kind of injury because you get swelling in here. And if you try to stand up straight, you compress these a little bit as you straighten out the bend in your back, and that compression hurts. And so I ended up like this. But I'm nice and straight now. It's amazing how scary, painful back injuries can be. I'm sure you've experienced this. We've all experienced these kinds of things in our life, I'm pretty sure. I certainly have in the past. Same sort of thing happening years and years and years ago, and I remember thinking to myself, I'll never be the same again. And I never was. So enough of that. Let's take a look at something else that failed here. So in my last short video I showed you some tubes that had cracks, basically breaks in the glass shell, and you get this white, you get a reaction on the getter that turns it white like that. So you see a tube like that, it's got air inside it. It's not just gassy, it's flooded with air. This one's really interesting, I think. It's a great big compactron tube, and has a large getter area. See, it's all gone white. Well, look at the tube. The tube is smashed, right? You can see the cracks in it. It's smash out. The thing I want to show you is what happened to the getter material, which in a good tube, do I have one? Good tube, would look to be painted on the inside of the glass, just beautifully, just right up against the glass. But I've seen this a number of times, and that's why I'm going to show it to you, if we can see it. It's maybe hard to see in the camera. Yeah, you can kind of see just looking straight on. This material, which was laid up tight to the glass, has popped away and is actually a dish shape inside now. There's a gap between the material and the glass. Why would it do that? Because during the reaction, when the air got inside the tube, and this material, whatever it is, started reacting, it expanded. Expanded slightly, and the forces, it'd be like freezing water, the force of ice. This would be like the force of ice, and it just popped itself off the glass, just lifted itself off the glass. This is the reason why steel rusts away. This reason right here. Because with steel, ordinary iron and steel, you get rust whose volume is much greater than the metal it came from. I mean, we know this, right? You see a piece of rusty steel. If it's really, really rusty, you see a big pile of rust on it. If the rust formed just right on the surface of the steel, it would not sort of disrupt itself, and it would form a coating, if you like, or a layer on the surface of the steel, and it would never pop off, and the steel would stop corroding. And we call that stainless steel. Stainless steel is steel with a few other things in it, chromium and molybdenum or whatever the stuff is that they put in, chromium for sure. And the result is, when the steel rusts, it no longer forms a rust coating which is bigger than the original steel. It forms a coating which is exactly the same. In the case of stainless steel, that rust coating, once it gets, I don't know, 4, 5, 10 atoms thick on the surface, it stops. Because it's now protecting the underlying steel with this very adherent, very strong coating, which is absolutely invisible. So when you look at stainless steel, for crying out loud, it's everywhere here. You swear that that's bare metal. You can take electrical connections and just touch it, and it makes electrical connection. Try that on a really rusty, don't try it on a really rusty thing, but you know what I'm getting at. So why? Because the corrosion layer on here is so thin that the electrons inside are able to drift through it and be on the outside of it, and that's why it still has a metallic sheen. The electrons kind of floating around, if you like, on the outside of this layer I'm talking about are preventing you from seeing the layer. You're seeing the cloud of electrons, which gives it the metal sheen. Oh my gosh, Peanut's at my door already. So anyway, I just like talking a little bit about corrosion so people understand what's going on. If stainless steel, you take something and abrade it. You can abrade off those atoms, just sand them off, file them off. Metal looks kind of the same, but it only takes seconds or minutes or some fairly short length of time for the layer to recreate itself. Now, if you take stainless steel, this will happen in your sink. You take a glass and you put it down in your stainless steel sink. Okay, a cheap stainless steel sink. You come back a day later because you're too lazy to do the dishes, and when you take the glass away, you see rust on your stainless steel sink, which you can clean away. You can clean it away, but you can see a little bit of rust, like regular reddish colored rust. What happened there? What happened was you put the glass on the stainless steel. You've scratched the stainless steel, maybe by doing dishes or something. You put the glass on top of it. Oxygen cannot make it under the glass to get back to the steel to reform the layer, and you get some other kind of corrosion. Iron chloride, is there such a thing? I don't know. Steel something going on. You can actually get stainless steel to look rusty like regular steel to a degree. So anyway, I love the corrosion thing. Corrosion, great stuff. Electricity, chemistry, just everything put together into the topic of corrosion to understand it. It's a wonderful, wonderful thing. Hey, it costs us more than anything else in our lives. We pay for a lot of corrosion. I see my cat left. He didn't like the corrosion talk. So we'll set these aside, and now what about this radio? Oh my gosh. So my last video ended with me attempting the IF alignment, finding it to be way out, discovering one of the IF coils is not normal. It's kind of a weird coil. And then right in the course of adjusting this one, suddenly the radio went wild. And it seemed to be an intermittent thing, and it seemed to be a physical thing, that moving stuff seemed to set it off or stop it. And then the next thing I noticed is it seemed to be related to the position of the volume control. You turn the volume control up about maybe 50% and nothing much is happening, and then you go another 5% further and the radio gets very loud and the weird stuff starts. What is all that caused by? I don't know. Chances are, well, there might be one problem and that's all, or there could be two problems in here, something to do with the volume control and something to do with tuning this and causing an upset in here. So I guess the name of the game is we'll get the radio operating and see what it's doing now, and carry on from there. Incidentally, when I first came in here, I just was looking at the radio, and what did I see? I saw, just a second here, that this coil is bent way off kilter. Like, they wouldn't install it on a funny angle like that, would they? And look at that. So what this tells me is probably this coil has taken a hit. I'm not the one. I did not do it. It's kind of out here on the corner. Look at this. The antenna wire is tied here. It's not the best arrangement. So I'm thinking somebody yanked on the wire and it pulled the coil over. I don't think so, though. I don't think it's. Maybe this is the intermittent spot. But if I was flexing the screw inside this IF can, putting a bit of a torque onto it, I mean, this doesn't bode well for problems right inside the can itself. You may have to take a look at. And what would that be? A trimmer capacitor that somehow, if you tighten it too much, it shorts? Let's get this guy going here and see what happens. I'll leave them up like this. And we have this connection. This might be responsible for the noise, for crying out loud. This was still connected. And what is this? This is a connection to nothing right now. So this is a connection to my signal generator. You know what? There could have been problems with this connection that were causing the deal. This is off. Maybe that's it right there. Maybe this fell off. And then the set was oscillating and I never noticed any of that. We'll put it on. I guess I'll turn on my signal generator too. Okay, everything should be good. I haven't done a thing in here to this radio since the last video. Here we go. Yeah, it's on. There, oh, there we are. So that just sounds like an extremely non-linear volume control. Okay, we'll start. This is connected. We'll start by disconnecting this. Yeah. Not much of a mystery here. You know what that sounds like? That sounds like a heterodyne in the IF. Let's turn this down a bit. I can't really turn it down. So the signal generator is running at the IF frequency, and we're hearing a tone. I think it's oscillating IF mixed with another, with this frequency here. Speaker test there too. You can see I've done the repair on the speaker, but okay. Let's see. Can't we quiet this down? There. Oscillation in the IF is usually caused by capacitors failing to null out signals on things like the screen circuits, and you end up simply feeding the output of the amplifier back into the input, because there isn't a capacitor there to catch it. Almost certainly one of these capacitors I changed is one of those. And it's a reasonable guess that I booped it up somehow at the incorrect size capacitor, or I've connected it incorrectly. And I tried to be as extremely careful as I could about getting this right. I tested the radio along the way too, but so if the oscillation's in the IF, then it's almost certain to be a particular capacitor that we can pick off. Who's there? Why, it's you! Yeah, okay, yeah, he's saying, let me out. He wants to go outside. That's what I'm going to do. Then we come back. Let me turn this power off here before I forget. When I come back, we'll look at the schematic and sort out what capacitor it might be that I have booped up on. We'll start there anyway. Okay, so here's the radio schematic here, and what I'm thinking is something from out here is making it back to here, and that's why we're hearing the oscillation. Could be between here, could be between here. Let's see what's going on. So I'm looking for the screen in this tube. It's not the easiest tube to spot the screen because of all these grids. The screen grid is number 2 and number 4 hooked together. They go out on pin 4 and they follow this wire. They're charged at 85 volts, and voila, this guy could be a bad actor. Let's just not stop there. Come down here. So on the other side of R5, did I change R5? The other side of R5, it's 175 volts, so it's quite a voltage drop there. This is a little interesting here. This is the first IF transformer. Oh yeah, tuned by capacitors. It's the second one, tuned by a single slug. A single slug. Okay, so I needed to get the answer to that question too. And I don't believe I've adjusted this one. I can't remember now. I had trouble at the top, but I can't remember if I resolved it or not. It wouldn't adjust. That's what I remember. So we come back here, looking for more capacitors. Hey, there's one right here. I think this is a big one. C2. They're coming right out of the power supply, basically, other side of the field coil. You're preparing the high DC voltage, high enough for plates, and then you're going to knock it down to work a screen. What about the screen here? 45 volts. It's got its own knocker downer. Got a bypass. I probably changed this. It could be if you don't change one of these. Like this is kind of doing the same thing, right? It's bleeding that. C9. Now, the smallest capacitors I didn't change. The C9 is a 0.05. I would have changed this one, 0.05 tubular. So that's been changed, but I could have made a mistake on it. So here's another one doing the same thing around this resistor, in fact. Oh, this is the chassis, too. Wow, there's quite a number of capacitors here that I think could influence the situation. Maybe even this one, right at the end of the IF. But I think, the way back, the feed path back, most likely is the screen, but it could also be the plate, and they're kind of coming from the same supply anyway. So we got to find C2, we got to find C5, and see what I did with them. C2 and C5. So one is right off of pin 4. And the other is a bit of a good luck, other side of this resistor. So the key is to find this, C5, oh, 0.1200. Tubular, 0.1. 200, okay. Let's go look. 0.1200. here's a 0.1 here. I'm gonna just pop the schematic up here where I can see it. So I'm gonna take a look at it. So this guy is tied to this pin, and this is the 6SA7. And what pin is it? It's pin 1, 2, 3, 4. Bingo! It's this guy, right here. You can certainly see it goes right to this ground terminal. I mean, it's definitely connected. Okay, there was another one. The other one is C2, which was one of the big guys. So let's find that R5. So R5 has to be this resistor right in here. And that looks like, what's that look like? Brown, green, brown? What's that look like? So R5 is a 15K. So that could be brown, green, orange. That would do it. I wonder if that resistor's off. Hard to see where it's going. So, other side of this capacitor, of this resistor, rather, should lead us to the other capacitor. I'm bending around in here, twisting to look at stuff. I can feel my back popping here and there. If I suddenly go down, you'll know I've hurt myself again somehow. I don't think that's going to happen. The other capacitor is the big one. 10. It's one of these. This brown wire, which comes right up into the area of interest. Right up onto this tube, and this tube is the output tube. This is almost certainly the bypass, if I remember it correctly. That's not going to do it. It's going to be one of these other two. So this one, the wire comes around to here. What am I expecting to find anyway? The capacitor I put in doesn't work. That doesn't make sense. And this one's just coming to this terminal. This didn't help. Maybe this terminal is wired on. It's going out. Looks like it's going out on the field coil, coming back to here. Oh God, help me. I'm lost. This didn't work out. So there's a pretty good schmozzle right in here. We should take a close look at this. There may have been problems with the wires shorting right in here. Let's take a close look at that and see if there is something going on there. And I noticed this when I was doing it, and I thought, whoa boy. Wow, it looks like some really terrible soldering jobs there. That's what that looks like. That looks just horrible. I didn't take the time to look at it under the magnifier here. Let me just get a tool. This could easily be a problem. It's plenty solid. Yeah, it's plenty solid. I mean, it's a terrible job, but it's solid. I'm worried there's a short right up in here. And you know, I guess in some cases, if you put these things too close together, wires too close together, there's a picofarad or two capacitive reactance between the wires. Maybe that's enough in some cases. Like, if that gimmick, you see the wire wrapped around there, I mean, if that's good enough to affect the radio, and it certainly is, that's why it's there, these other things could do it. Push this out a bit. So I'm looking at the wire back in here. Well, no. Let's start the. I'm going to resolder those two spots so they look nice. I think they're quite functional the way they work, but rather ugly looking. Oh. So, hey, on the pandemic front here in Canada, we're all panicking. Well, no, we're panicking as much as Canadians panic. we're not prone to panicking here in Canada. But it's clear that the virus is going out of control. And towards the end of the summer there, like I think a lot of countries, people in Canada got pretty relaxed about things. And the result is we are climbing rapidly right now. See, from this distance, these solder joints look fine. As I say, they probably aren't the problem at all. So this was one. You know, I've checked this. I mean, I tested this before I put it in. It's a good capacitor. It's a bit of a vintage guy, but not that old. We should try the radio again, just in case. Just in case. You know what? I still have. You know, I'm kind of stupid about this, aren't I? I still have the. This connection could be the whole problem. I take away this connection and the problem goes away. So the test is the cause. That's possible. Oh, let's do that. And ready again. We also have this meter connected at the speaker here. Good. Okay. There we go. What will you do this time? I meant to wiggle this too. Well, I don't hear any hollering. Oh, of course, I retuned the signal generator. So the idea would be that right now, even though we can't hear it, there's an oscillation in the IF. There's no modulation associated with it, so we can't hear anything. When I bring this into the IF frequency, it begins to mix with the oscillation that's in there, and we hear the tone. There it is. So now the thing is, I'm going to disconnect the signal generator. Of course, we're not going to hear the tone anymore. How much you want to bet that's the actual cause of this problem? So what we can do is we can try to pick up a radio station. You know what? Let's do this. Let's go here. We're going to go on the antenna. The radio's tuned to 800. Okay, we'll dial up 800 here. So I'm going to give it, I'm going to let it, that's a pretty strong signal. There it is. So now you hear the heterotime. So what this is telling me is there really is an oscillation in this radio at the IF frequency. Now another possibility is I've literally made the radio too hot. I've tuned the IF transformer so well that the thing is bound to oscillate because it's just too good. Yeah, I don't know about that. And now I remember about the other IF coil, and I was trying to adjust it. This must be the slug. I booped it up and I broke the top. So that presents another problem too. So what if we detune? If we detune, my theory would say detuning it and the oscillation should go away. Wow, that was too easy. I'm gonna blow the speaker up. Okay, what's going on here? Now, with the volume turned down, oh, listen to that. What is that? Let's try that again. What is making the click? I think it would be the speaker, of course. But it has a bit of a weird sound to it. It's lots of fun, eh? Oh yeah, it's the speaker. Whack my finger there. What exactly is that? I don't know. It is a great radio. Coming back to the same thing, it's oscillating in the IF circuits where it shouldn't. Okay, let's move this coil. No, that's not doing anything. And just for fun, let's push on this tube. Hey, hey, hey. I don't want to touch the chassis here while I'm doing this. No. What about this one? Why is it related to the volume control? The volume control is doing more than just making it go loud. Yeah. Morse code coming through there. So how can the volume control be implicated in this whole thing? Volume control appears to be controlling the amount of feedback. Really? Volume control. Can I turn this down a little bit? Yeah. Volume control is where? Where? Where's the volume control? Hey, wait a minute. Am I blind? There's no volume control. That's the problem. Oh my God, don't tell me that's the volume control. R1. Volume control. Look where they've got it. Oh my gosh, this is something that was done with radios 10 years earlier than this. Oh my God, okay. Well, if this is how they've done this, this is the clumsiest thing. This is basically shorting out the antenna. Wow, that's what the volume control does? It's just, I'm stunned. Seen it in old radios, but never one like this. Okay, well that's a stunner. This radio is, so that would mean that this is all running kind of wide open all the time, this amplifier here. Now there's an AVC. Is there AVC developed in here? So we'll find the... wait a minute, what is going on here? Because this is the... I'm misinterpreting this radio entirely. So this is an IF transformer, meaning it's working at 455. What's going on with this thing? Because you need to rectify the signal that's going over here. So let's go over here, follow the grid back. So there's diodes here, and I've never seen this before. One goes to the primary side of this, and the other one's just grounded out and gotten rid of. So we got a rectified signal in the primary here. You can still get transformer action from that, but you would then have only the AC portion over here. Is this like a form of detector? The detector is here. So C14 is a big guy, 260 pico, it's not. R7's a big guy, R7, sort of, $250,000. And then what's left here is sent back as the AVC. So we get an AVC action out of here, on here. This guy can also be causing oscillation and feedback problems. You wouldn't expect it necessarily at the IF frequency. I think that's the case there. Wow, okay, so this is kind of a weird, it's a weirdo radio. It's weird. Weird radio. Wow, that really kind of changes everything up. So that means when I'm turning the volume control, I was imagining I was doing something over here with the audio. I'm actually doing something with the RF back here. This might start implicating like this capacitor, C7.1. So what are they trying to do here? So they want the signals to be grounded at this point. The AC part of the signal. So it's dropping over R11 and R1, and that's pushing it through this coil. So R11, how big is R11? R11, 50 ohm, it's almost nothing. So R11 is very small. Why it's there? Probably some kind of oscillation suppression, rather than just have a straight wire through here. Something like that. And R1 again. Volume control. What is it? Give me the value. Give me the value. Where's the value? You didn't give me the value. I'm just like, we can guess it's something fairly big, but I don't know. But anyway, when you turn the volume to 0, that would actually, putting this down here would max out the volume. Putting this up here would kill it. As we're coming along here, we're affecting the apparent resistance that this coil is working with here. Well, that certainly explains why the volume control behaves weirdly. Behaves weirdly. Now going back, so this is an ordinary IF running at 455. We come over here, the output goes to the grid cap, goes to the first grid. Great. The output from the tube wait a minute, let me say that again. Let's do this grid. Now wait, now this is also not quite normal. You don't normally take the output. This would be 455 kilohertz here. Run it through another amplifier. Well, this would be like the IF amplifier. Have it come out. Wait a minute, where's this wire going? There's one over here. What? That's the secondary side. Well, I wonder if there's something really odd about this tube that requires some kind of care. 6B8G, I can't say I've heard of that one before. 6B8G. I think it's time to do a little research on this tube. This circuit arrangement is different enough from what I usually encounter, or what's in most radios, that there's something curious going on here. That's for sure. Yeah, I'm going to stop and do a little research. 6B8. Well, okay, studying this schematic and looking for information about the 6B8 tube hasn't paid off at all. So I'm going to try an approach here. It's my own idea, so it probably won't work. I'm going to start the radio up, get it oscillating here. Then where's the oscillation? Can't hear the oscillation. I don't have a heterodyne signal being fed in, so I need to feed in something here. Wow! Just sounds like a switch flipping, doesn't it? Not getting quite what I want here. Let me turn off the internal modulation here. Where's the howl? I should still hear the howl. Weird stuff. Why no howl? Turn it up. The nice howl has gone. Where'd it go? I pulled out the 6B8 tube to have a look at it and put it back in. Did that do something? So this radio is really meant to have a glass version of the 6B8 tube. Get out of there. With a shield on the outside of it. Yeah, this is kind of scary here. Get it over there. But instead it has the metal tube. Pin 1, I checked it, is definitely grounded. I checked it by pushing a test probe down into pin 1 on the socket, and it's definitely grounded. So, whoa. I would have preferred those tones. Where'd they go? Or was I fooled all this time? All kinds of weird stuff going on here. There we are. Okay, I need something like that. Something that's kind of on the edge. And then what I'm going to do is I'm going to touch various leads in here and see if one of them really upsets the radio from where it is now. This isn't the best screwdriver. I'm thinking it's very sensitive to any variation in the circuit. If I touch it, it should cause a significant variation in the operation of the radio. To the volume control here. Oh, maybe not. No. So there's a wire that goes from this terminal here. Comes up on top here. Oh, what a change. Comes up on top. Just fishing around. Fishing. We're on a fishing expedition. Metal right there that I'm contacting the antenna. Yeah. Well, it's not really the answer's not jumping out at me. That's right where that gimmick is, right there. The gimmick wire. So there's so the gimmick is a wire, bare wire, wound around the insulation of another wire. And the other wire, where does it go? It doesn't go anywhere. It's just coming from where? Coming from the back. Oh, I've got my phone here. Oops. Okay, so I hope I didn't produce some interference on the video there, but a lot of wires really close together here, bent in a funny way. Can you see that? So you can see this wire here bent in a funny way right next to this one. You can kind of just see the end of the wires, just the end of the insulator wires just down behind here. And this wire comes around here. Turn it up again. We're not getting the oscillation here that I'm trying to hunt down though. Where did it go? It seemed like I got rid of the modulation. Got rid of the modulation, I got rid of the heterodyne. Let's put the modulation back on. And I gotta tune it in. This is a sad situation going on here. Way too strong of a signal. It was just possible that the things that are disturbing me are actually, in this case, are actually quite normal sounds coming through a speaker that's still full of holes. There's a hole here, still full of holes. Making me think there's something wrong. If I put this through a nice speaker, we would just hear that this is just hummy interference sounds and nothing too dramatic really. See, like it's just picking up some interference here, but the speaker is so rattly. Well, where did the oscillation go? Is this now working? Okay, let's take this off. Take that off. And we'll stick on an antenna. Oh my gosh, the antenna is hot diggity dog. I'm gonna have to work on the speaker some more for sure. That speaker's going wild. I got my thumb on it. It's just going wild when I. Nobody's coming in. What's rattling? Well, I'm going to assume it's just all these little breaks in the speaker here that are making the buzzing sound. This radio seems to be working. What the heck is going on? I pulled out that tube and stuck it back in, and that solved it? Is that what did it? I don't know. I don't know. what to think. I think this. I got to fix up that speaker some more. Well, that's just a crazy radio session here. I'm not sure it really got anywhere. Okay, so I think I'm going to give this guy one more try. No equipment connected. Outdoor antenna clipped on to the antenna bundle here. Let's give it a go. I have not repaired the speaker at all. It's just well, it's actually working pretty good. Where did more sensitive up at this end, but I have not done the alignment. Okay, so it's actually working surprisingly well. Don't know what happened to the tone. Maybe it was something I had, the way I had it connected was doing that interference thing, the heterodyne thing. Maybe it's the extremely sensitive here, eh? Look at that. Could even have been just the way this wire was put on here. Maybe, I don't know. I don't know. I don't know. But it seems to be gone now, so can't do much about it if it's gone. I'll have to carry on with the rest of the work on here. So that was a bit of a runaround today with kind of a weird result, but there you go, eh? And but anyway, Jim, say something useful. We'll see you on the next video. That might be useful.